Let's start the review for section 4.5. Question 1. Solve the exponential equation. Express irrational solutions as decimals correct to the nearest thousandths. We have 1/2 raised to the x is equal to 13. The first step is to bring that exponent to the front of this equation. And in order to do that, we're going to take the natural log of both sides. This is the natural log of 1/2 raised to the x equals the natural log of 13. And with that, we can use the power rule. It allows me to bring the x in front of the equation. This is x times the natural log of 1/2 is equal to the natural log of 13. Now there's multiple ways to do this problem, but I find that taking the natural log of both sides is the easiest for me. The next step is to isolate that x. Well, I can divide both sides by the natural log of 1/2. And this divides out with this term here on the bottom. We have x is equal to the natural log of 13 divided by the natural log of 1/2. We can enter this now into a calculator, and we should get our solution. We'll enter the natural log of 13, close the parentheses off, and divide it by the natural log of 1/2. And this will give us our solution, -3.700. Our solution is -3.700. Question 2. Solve the exponential equation. Express irrational solutions as decimals correct to the nearest thousandths again. 5 raised to the x plus 3 equals 4 raised to the 2x minus 2. Again, we have exponents that have variables attached to them, so we'll have to take the natural log of both sides. The natural log of 5 raised to the x plus 3 is equal to the natural log of 4 raised to the 2x minus 2. With the power rule again, I could bring the exponent to the front. Again, I'm going to bring that 2x minus 2 to the front of my natural log. This becomes x plus 3 times the natural log of 5, and that's equal to 2x minus 2 times the natural log of 4. I'm being careful with the parentheses because when you bring it to the front, you're actually multiplying it with the expression. Now we have to isolate and solve for x. In order to solve for x, I'm going to distribute the natural log of 5 to the x plus 3, and that will give me x times the natural log of 5 plus 3 times the natural log of 5. Same thing on the right side, we'll distribute the natural log of 4 to 2x minus 2. This gives me 2x times the natural log of 4 minus 2 times the natural log of 4. Now we got to begin by moving the x's to one side of the expression and the numbers to the other side. We have to isolate the x variable, so let's start moving things to their appropriate sides. Let's subtract 2x times the natural log of 4 to both sides. We will subtract 2x times the natural log of 4 to both sides. And we'll also subtract 3 times the natural log of 5 to both sides. And this will cancel out this term. This gives me the following. X times the natural log of 5 minus 2x times the natural log of 4, and that's equal to -2 natural log of 4 minus 3 natural log of 5. Now I can factor out the x's. Notice we have these two x's. Let's use factoring. This is x times the natural log of 5 minus, we're going to factor out the x, so that leaves us 2 natural log of 4 equals negative 2 natural log of 4 minus 3 natural log of 5. And finally, I could divide both sides now to get the x by itself. Let's divide both sides by the natural log of 5 minus 2 natural log of 4. Again, divide both sides by the natural log of 5 minus 2 natural log of 4. Then we can finally enter this in a calculator. So type this entire expression in a calculator. Let's enter the equation into our calculator. We'll start off with the parentheses. Negative 2 natural log of 4. Then we'll subtract 3 natural log of 5. Close that off. And we'll close off the parentheses for the numerator. Then we'll divide that by the denominator. Start off with another parentheses. This is the natural log of 5 minus 2 natural log of 4. And we'll make sure we close off the parentheses for the denominator. Click enter, and we have our answer, 6.535. Approximately 6.535 is our solution. Here's our solution. X is approximately 6.535. Again, be careful with the calculator. Make sure you put parentheses on the numerator, parentheses on the denominator, and then you should get the same answer, 6.535. Question 3. Solve the exponential equation. Express your solution in exact form. To do this question, notice that we have 2e to the 2x plus e to the x equals 28. It's going to be very difficult to take the natural log of both sides because we have two terms on one side. So we're going to subtract the 28 to both sides instead and try a different strategy. This gives us 2e raised to 2x plus e to the x minus 28 equals 0. Now this looks something that is factorable. Let's use substitution so we can see why this thing is factorable. Let's let u be equal to e to the x. That's my u substitution. So this is going to replace these e to the x's with the letter u. This becomes 2u squared plus u minus 28 is equal to 0. Now this is something I know how to factor. We're going to use the AC method. Multiply 2 times negative 28. That's negative 56 on the top and a 1 on the bottom. We know 7 times 8 is 56, but in order for this to be negative, we need a negative 7, and this does add up to a 1. We'll use the bottoms up technique here. This would be a 2u on the bottom and a 2u on the bottom. I can simplify this as negative 7 over 2u. This one simplifies as 4 over u, and using the bottoms up technique for factoring, we have this is equivalent to 2u minus 7 times u plus 4 equals 0. Solving each of these equations separately, I have u is equal to 7 over 2, or u is equal to negative 4. Now remember, u is equal to e to the x. So let's do substitution back. This gives me e to the x equals 7 over 2, or e to the x equals negative 4. Now in order to solve this for x, we'll take the natural log of both sides. The natural log of e to the x equals the natural log of 7 over 2. And this one is the same. It's the natural log of e to the x equals the natural log of negative 4. What happens to the natural log of e to the x? Well, that's equivalent to just x. X is equal to the natural log of 7 over 2. That's our first solution. Now on this side we have a problem. We cannot take the natural log of a negative. So on this side we have no solution. That means our only answer is the natural log of 7 over 2. Question 4. Solve log base 3 of 5x minus 4 equals 3. I'm going to use the definition of the log. Recall, log base b of x equals y implies b to the y equals x. So we're going to use the definition. This is saying the base raised to the exponent should be equal to 5x minus 4. Well, we know 3 cubed, that's 27. 27 is equal to 5x minus 4. And this just becomes a simple equation. Let's add 4 to both sides. This is 31 equals 5x, and x is just 31 over 5. That's our solution. You could check your work by plugging in that value into the x to make sure this is correct. But this is a good solution, 31 over 5. Question 5, solve for x again. We have log base 4 of x plus log base 4 of x minus 6 equals 2. This problem requires the product rule. Recall, log base b of x plus log base b of y equals log base b of x times y. We can multiply the arguments together. This means I can replace the left side with log base 4 of x times x minus 6, and that's equal to 2. Then we could use the definition of the log. Log base b of y is equal to x implies b to the x equals y. So this is saying 4 squared is equal to x times x minus 6. We know 4 squared is 16, and we can distribute this x. That's x squared minus 6x. And this looks like it's a factorable equation, so let's try to factor it if possible. We have x squared minus 6x minus 16. This factors as 8 and 2, and this should be a negative 8. We have x minus 8 times x plus 2. Solving these for x, we have x equals 8 or x equals negative 2. Now since this is a logarithmic equation, you have to check your work. So plug in 8 into the original equation and see if it's satisfied. And in this case, x equals 8 is a good solution. But if you were to plug in a negative 2, notice the argument here would be negative. So negative 2 would not be a good solution for question 5. The only solution is x equals 8. So double check to make sure you don't have any negative arguments. Question 6, solve the equation. Natural log of 7x plus 15 minus the natural log of x equals the natural log of 8. Let's recall the quotient rule. Log base b of x minus log base b of y is equal to log base b of x divided by y. That means the left side can be translated as the natural log of 7x plus 15 over x equals the natural log of 8. Recall the formula. The log base b of x being equal to log base b of y implies x equals y if they have the same base. And in our case, they do have the same base. So I can say 7x plus 15 over x is equal to 8. I can just remove the natural logs since they have the same base. We can solve for x. Let's multiply both sides by x. This cancels out the x's. 7x plus 15 equals 8x. And then I could subtract 7x to both sides. We have 15 is equal to x. Now we got to double check to make sure this is a good solution. Plug it back into the original equation, making sure that you're not taking the natural log of a negative. And in this case, we're good. This is a good solution. For question 7, let's find the interest rate to the nearest hundredth of a percent that will produce $2,500. If 1,500 is left at interest compounded quarterly for 4.5 years, use the formula A equals P times the quantity 1 plus R over N raised to the Tn power. Now we know this is compounded quarterly. That means N, the number of compounds, is equal to 4. The time frame that we're looking at here is 4.5 years. That's RT. The principal is the initial deposit, which is given as 1,500. And our final amount should be 2,500. Let's plug in the values. We have 2,500 equals 1,500 times the quantity 1 plus. Now I don't know the interest rate, we'll leave it as R. The number of compounds is 4. Raise that to the T times N, so that's 4.5 times 4. I'll simplify the 4.5 times 4. So this is 2,500 equals 1,500 times 1 plus R over 4 raised to the 18. That's from multiplying 4.5 times 4. Let's divide both sides by 1,500 to isolate that variable. 2,500 divided by 15 reduces to 25 over 15. And that's equal to 1 plus R over 4 raised to the 18. Now I could simplify 25 over 15 further. They're both divisible by 5. This simplifies the equation to the following. 5 over 3 equals 1 plus R over 4 raised to the 18. Now we could take the natural log of both sides to bring down that 18 to the front, but I think it's easier to take the 18th root of both sides. Let's take the 18th root of both sides, and that's going to cancel out that 18th power. This gives me the 18th root of 5/3 equals 1 plus R over 4. Now we could solve for R. This gives me, by subtracting 1 to both sides, the 18th root of 5/3 minus 1 equals R over 4. We can multiply both sides by 4 now. And this gives me R equals 4 times the 18th root of 5/3 minus 1. Now you're going to have to use a scientific calculator to enter this into the calculator, and you'll get your answer. R should be equal to 0.115, which means our interest rate is equivalent to 11.5%. So double check with a calculator. This is 4 times the 18th root of 5/3 minus 1.